this question says, how do we use a manometer to measure pressure of a given gas? So manometer is a device which helps us to measure the pressure of a gas. It's made up of a U-shaped tube filled with some liquid or a certain liquid, and it is one end is connected to gas which we are measuring it is pressure. This is the pressure of a gas, and the other end is either open to atmosphere or closed. That means we can have a closed end manometer and the open end manometer when one end of the tube is open to the atmosphere. So we have pressure of the atmosphere or PATM here, and this is the pressure of the gas we are measuring. So let's see each one by one. So in the case of the closed end manometer, the pressure in this gas push the liquid in this manometer to one side. That means the liquid in this region pushed by the pressure of the gas, and liquid will rise to this height, and on the other sides the liquid reduced. Then we can get the height differences of the liquid, delta H. Then we apply that if the liquid and the gas boundary when it is pushed by the gas pressure is here. Let's say this is pressure at some point PA, and also we can make the parallel line at this point, and this point is, let's say, B, then the pressure at this point is PB. Then by the hydrostatic equilibrium, the pressure at point B must be equal to the pressure at point A. So pressure at point A is the pressure of the gas which is pushing the liquid columns in the cylinder or in this tube or manometer, and this other end is the pressure at point B is the pressure due to the column of this fluid with a density rho. So by using the concept of hydrostatic equilibrium, pressure at point B is the pressure due to the column of the fluid above point B, that is rho times G times the height difference, which must be equal to pressure at point A is the pressure of the gas in this cylinder which is pushing the column of these liquids through these tubes. So we can say this is the pressure of the gas. So pressure of the gas in the closed end manometer is equal to the pressure due to the column of the liquid inside this manometer. So when we come to the second case, when the one end of manometer is open to the atmosphere, then we have atmospheric pressure pushing the liquid columns down, and here we have the pressure of the gas also pushing this liquid column down to these sides. So this liquid has some density rho. If this pressure of gas is greater than the atmospheric pressure, the liquid column may be pushed to some point is here. Let's say this is point A, and on the other sides the liquid column will pushed up against the atmospheric pressure, and we have some height differences. Let's say this is delta H. So when we draw a straight line to the A and we call this point B, then the pressure at point B is due to the pressure of the fluid column above point B and the atmospheric pressure. So pressure at point B is equals to the atmospheric pressure plus the pressure of the liquid column above point B, which is rho times G times H. And the pressure at point A is equal to the pressure of the gas, which is pushing these liquids down to this side, which is equal to, let's say, pressure of the gas. So here also we can use the concepts of hydrostatic equilibrium. Pressure at point B must be equal to pressure at point A. This is hydrostatic equilibrium. So then we can say that pressure of the gas, P gas at point A, must be equal to the P atmosphere, the atmospheric pressure, plus rho times G times H, where rho is the density of the liquid we are using in a manometer. So by this concept we can measure the pressure of a gas using a manometer. So let's see each alternatives of the question. So alternative A says that the pressure at the surface of the open end manometer is the same as the gas pressure in the closed tube. So this is completely false, because when we use the open-end manometer, pressure of the gas is not equal to the atmospheric pressure only. It is the sum of the atmospheric pressure and the pressure due to the liquid columns. B says the principle of hydrostatic equilibrium is considered to measure the pressure of unknown gas. So this is correct. In both cases, we use the principle of the hydrostatic equilibrium to measure the pressure of unknown gases. So alternative C says that the gauge pressure in a fluid in an open end equals to the gas pressure in the closed tube. So this is also false, because the pressure of the gas is not equal to the gauge pressure, or it's not only rho GH. It is the atmospheric pressure plus the rho GH, or the gauge pressure. That is the pressure due to the liquid columns in the manometer. So alternative D says that the gauge pressure equal to the atmospheric pressure. So the gauge pressure cannot be equal to the atmospheric pressure. The atmospheric pressure plus the gauge is equal to the pressure of the gas in the open end manometer. But in the case of the closed end manometer, the gauge pressure is equals to the gas pressure, closed ends of the manometer. So we can say that the correct answer is on alternative B. So this question says that consider two balls A and B projected with the same speed or the same velocity v naught at angles theta 1 and theta 2 respectively. That means two balls A and B are projected with the same initial velocity but at two different angles, which is theta 1 and theta 2. So the first ball A, is projected at an angle theta 1, where theta 1 is between 0 and 45. That is, theta 1 is greater than 0 and less than 45 degrees. And the second ball B is projected at theta 2, which is theta 2 is between 45 and 90 degrees. So the question says, which of the following statement is correct about the motion of the balls? That means the balls A and B. So alternative A says that ball A takes longer time than ball B to reach its maximum height. So we know that the time to reach maximum height of the projectile is given by directly, it is U times in sine of the angle of projection divided by the G, gravity. This is the time to reach the maximum height for any projectiles. So when we compare the Tmax of the projectile A is V naught times sine of theta 1 divided by G, and for the second ball, the time to reach the maximum height is given by V naught sine of theta 2 divided by G. So the alternative says that the time to reach the maximum height for ball A, that is T maximum of A, is greater than T maximum of the B. So which balls takes the longer time to reach its maximum height? So we can compare from the given. So easily we know that the sine of the smaller angle is the small number, already you know, and as the angle increase, the sine of that angle is also increase. So as we see from the given, theta 1 is from 0 to 45. That means the sine of 0 to 45 is less than the sine of 45 to 90 degree, since the sine of 0 is 0 and the sine of 90 is 1. So this means that the time taken to reach the maximum height for ball B is greater than the time taken for first ball A to reach its maximum height. So this alternative is completely wrong, which says T of A is greater than the T of B, but D of B is greater than T of A. So alternative A is not correct. So alternative B says that the range of ball A is smaller than its maximum height. So let's compare both the range and heights for ball A. So range of the ball or range of projectile is given by the formula 2 times the initial velocity square times the sine of the launching angle times the cos of the launching angle divided by g, or more. We can simplify this equation by using the trigonometric identity, which is u square 2 times sine theta times cos theta is become the sine of twice of theta divided by g. This is the range of the projectiles. So for ball 1, range of ball A is equals to, since the initial velocity is v naught square sine of twice of theta 1 divided by g, and the height of the projectile is given by height is equals to the initial velocity square sine square of the launching angle divided by twice of g. So this is equals to, for ball A, the height of ball A is equals to v naught square times the sine square of theta 1 divided by twice of g. So we have these two equations for ball A. So when we compare these two values, since the values of theta 1 is from 0 up to 45 degree, then the sine of theta 1 is increases as the angle increases from 0 up to 45. So we have 0 at 0 degree, and the values increase between these two values, and at 45 sine of 45 is, we know, radical 2 over 2 or 0.707 exactly. So when we compare these two values, the height under the range, so range of ball A, the maximum possible range we have is at theta is 0, the range is exactly 0, since sine of 0 is 0, then we make it simply 0. This means that at 45 degree we have v naught square, the sine of twice of theta 1 divided by g. So the maximum values of theta 1 we have here is 45 degree. When you substitute 45 degree here, so 2 times 45 is 90 degree. Sine of 90 degree is 1. Then the maximum values of range of ball A is v naught square divided by g. And for the height of ball A, which says that height is v naught square sine square of theta 1 divided by g. When you substitute the maximum value, since when theta is 0, the height is also 0, then the maximum values of theta 1 we have here is 45 degree. Sine of 45 degree is radical 2 over 2. Then when we square it, we get exactly 1 over 2. So, sorry, we have here 2g. Then we have finally the maximum height at 45 degree is given by v naught squared divided by 4 times g. So when we compare these two values, the range at 45 degree is v square over g, and the height, the maximum height at 45 degree is v square divided by 4g. So when we compare these two values, that means v naught square over g is greater than v naught square over 4g. That means the range of ball A is greater than the height of ball A. For theta 1 is start from 0 up to 45 degree. So this alternative is completely wrong, because the range of the ball is not smaller, it is greater than the height of the ball. So alternative C says that the ranges of the two balls, that means range of ball A must be equal to range of ball B when the sum of theta 1 plus theta 2 is equals to 90 degree. So this is always true for any complementary angles. That means complementary angles are the two angles with the sum equal to 90 degree. So for any projectiles launched, any two projectile launched with a different angles, but those angles are complementary with each other, then the ranges of those projectiles are always the same or equal. So since theta 1 plus theta 2 is 90 degree, so theta 1 and theta 2 are complementary with each other. So then the ranges of these two projectiles are the same. So this is always true. When we come to the alternative D, both balls have equal speed at their respective maximum height. So at the maximum height, the speed of the projectiles are only the horizontal speed. That means the vertical speed is 0. So we have the Vx. So Vx is equals to the initial velocity x, which is equals to the initial velocity times cos of theta. The speed at the maximum height for A is the initial velocity v naught times the cos of theta 1, and for ball 2, velocity at the maximum height of B is v naught times cos of theta 2. So since theta 1 is start from 0 to 45 and theta 2 is from 45 up to 90 between this value, and theta 1 is also between 0 and 45 degree. So when we compare these two values, since the balls have equal initial velocity v naught, so when we compare the projectile launched with the smaller angle has the larger velocity at its maximum height, and the projectile launched with the larger angle will have the smaller velocity at the maximum height. Or in general, we can say that since theta 1 and theta 2 are different, these two velocities are not equal. VA is not equal to, or the velocity of ball A at maximum height is not equal to the velocity of ball B at the maximum height. So the correct answer for this question is on alternative C, which says the ranges of the balls are the same when the sum of the angles are equal to 90 degree, or when the two angles are complementary with each other. So question number 14 says a car initially traveling at the speed of 20 meters per second undergoes a constant deceleration of 1.5 meters per second squared. So if the radius of each tire is 0.3 meter, then how many revolutions does each tire make before the cars come to rest? So to do this, first of all, we have to find the distance traveled by the car when it's finally come to rest. So after we got that displacement is, or the stopping distances of the car, then we can find theta in revolutions by dividing the distances, the circumferences of each tire, which is 2 pi times r. So when we first of all get this number and divide it by the circumferences of the tire, we get the revolution which is made by each tires of the car before it come to rest. So when we proceed this calculation, since we know initial velocity of the car, the deceleration, and finally it come to rest. That means we have the initial velocity u and final velocity 0, and we have an acceleration. Then we can find the s using the equations of uniformly accelerated motion. V square minus the u square is 2as. Since final velocity is 0, that is the cars come to rest. So we can find that s is equals to the negative of u square divided by 2 times a. So when we do this, minus of initial velocity is 20 meter per second, the whole square divided by 2 times acceleration is negative 1.5 meter per second square, since the car is decelerating. So when we do this number, the distance traveled by the car before it come to rest is, this is minus 400 meters square per second square divided by minus 3 meter per second square. We cancel second square by second square, 1 meter by 1 meter. These negative cancel each other, and we have 133.33 meter traveled by the car before it come to rest. So when we divide this number, theta in revolution is equals to the distance traveled by the car divided by the circumferences of each tire, which is 2 pi times r. So 133.33 meter divided by 2 times the pi times 0.3 meter of each tire. So this meter cancel each other, and when we proceed this number exactly, we get 70.77 revolutions. So the correct answer is on alternative A. Question number 15 says that a constant tangential force is applied on a rim of uniform solid disc of mass 50 kg and radius 0.5 meter. So if the angular speed of the disc changes by 1 revolution per second within 2 seconds, what is the magnitude of the torque produced by the force? So the moment of inertia of the disc is given by a half of m times r squared. So velocity, angular velocity delta omega is changed by 1 revolution per second in every 2 seconds. So by using this concept, we can easily calculate the angular acceleration. So before going to that, we have to convert revolution per second into rad per second into the SI unit. Since 1 revolution is equals to 2 pi rad, so delta omega is equals to 2 pi rad per second. So then the angular acceleration alpha is delta omega divided by delta t, which is 2 pi radian per second divided by 2 seconds, which is directly equal to pi rad per second square, is the angular acceleration of the disk, since the force is exactly acting perpendicular to the radius at the rim of the discs. So these discs will gain the angular acceleration. That means angular velocity is increasing each time. So then what is the values of the torque that these discs can gain? So we can use directly by using the Newton's second laws in rotational motion, which says the torque is always equal to the moment of inertia times the angular acceleration, exactly. Since the moment of inertia of the disk is a half of mr square times the angular acceleration, so we have all values, and directly when we substitute, a half of mass is 50 kilogram times radius is 0.5 meter, the whole square times the angular acceleration is pi times rad per second squared. So when you proceed this number directly, we can get is equal to 19.6 Newton meter. So the correct answer is on alternative B. Question number 16 states that a loop of 0.1 meter in diameter is placed in XY plane in a uniform magnetic field of 0.6 Tesla that is perpendicular to the plane of the loop. Then what is the net magnetic flux through the coil? We can say that the loop is circular loop, which is 0.1 meter. So the radius of the loop is 0.1 meter divided by 2, which is equal to 0.05 meter. So the loop is circular in shape. It has the radius r, which is equal to the half of its diameter, and the magnetic field is exactly perpendicular to the plane of the loop. This means the magnetic field is plane of the loop perpendicular to it. This means that all the magnetic field lines are passing through area of the loop A. So the magnetic flux phi B, which is equals to the dot product is of the magnetic field and the area vector A, that is, which is equals to B times A times cos of angle theta. So in this case, angle theta is the angle between the magnetic field and the normal of the area. So normal of the area is perpendicular to the area itself, and the magnetic field is also perpendicular to the plane of the loop. That means in this case theta is exactly equal to 0. That means the normal of the area and the magnetic field B are parallel with each other. So all the magnetic field lines are passing through the plane of the loop. This means we have the maximum flux. So the maximum flux of the magnetic field when the magnetic field lines are parallel with the normal of the area is simply it is the product of the magnetic field times the area of the loop. So when we directly substitute the number, the magnetic flux, the maximum magnetic flux is given by the magnetic field strength, which is given 0.6 Tesla times the area of the loop, which is in circular, pi times r square. This number is equal to 0.6 Tesla times pi times 0.05 meter square, which is directly equal to 0.0471 Tesla times meter square, which is equals to Weber. So then we can make this number 1, 2, 3. So the magnetic flux is equal to 4.71 times 10 raised to minus 3 Weber. So the correct answer is on alternative D. So question number 17. The following table shows the density of the different objects at the room temperature, which is 20 degrees centigrade. Based on the information given in table, if we identify substances that sink and float with respect to the other substances. So we compare the density of the substance given here in this table and we going to judge all alternative. So alternative A says that water, gasoline and ice will sink into the seawater. That means we have to compare the density of the seawater with that of ice, that of gasoline and that of water. If the density of the seawater is greater than all those materials will float this over the seawater. But if the density of the seawater is less than these materials density, then the seawater will float over the other. So we can see that water, gasoline and ice will sink into the seawater. To sink in the seawater, the water the gasoline and the ice must have the density greater than that of the seawater. So when we compare, seawater has a density of 1025 kilogram per meter cube, but the density of the normal water is only 100. That means the water cannot sink into the seawater, it floats. When you come to the gasoline, gasoline has a density of 680 kilogram per meter cube. So the density of the gasoline is also less than that of the seawater. So it do not sink into the seawater, it's float over the surface of the seawater. And when we see the ice also has a density of 916 kilogram per meter cube. So it will float over the seawater, which has a density of 1025 kilogram per meter cube. So alternative A is not correct. When you come to alternative B, bone, iron, and seawater will sink into the water. So to sink into the water, the seawater, the iron, and the bone must have the density greater than that of the water. So when we come to the bone has a density of 1800 or 1800 kilogram per meter cube, which is greater than the density of water, which is equals to 1000 only. So the bone will sink into the water. It is true. When you compare the iron also has the density of 7860, which is greater than that of the water. So the iron will sink in the water. It's also true. When we come to the seawater also has a density which is a little greater than that of the normal water or the pure water. So it will also sink into the water. So alternative B is correct. When we come to alternative C, gold, lead, and copper floats in the gasoline. So to float in the gasoline, the density of gold, the lead, and the copper must be less than the density of the gasoline. So let's compare it. The density of the gold, which is equal to 1930, is greater than that of the gasoline, which is only 680. So the gold will sink in the gasoline. It will not float over the gasoline. So the blade, which has the density of 1060, has a greater density than gasoline, so it will sink. And the copper, which also has a density of 8920, has a density greater, so it will sink, do not float. So alternative C is completely wrong. Gasoline, ice, and the blade float on the surface of the water. So to float on the surface of the water, the density of the gasoline, ice, and the blade must be less than that of water. But if we compare it, the density of gasoline is less than that of water, so it will float over the surface of the water. But the density of ice is also less than that of the density of water, so it will float. But when you come to the blade had a density of 1060 greater than that of water. It do not float, so it will sink. So this makes the alternative D completely wrong. So the correct answer for this question is on alternative B. So question number 18 states a 12-volt source is connected across the primary coil of a transformer having a 600 turn. If the secondary coil of a transformer has a 1000 turn, what will voltage appear across the secondary coil? That means V secondary is how much? Transformer is a device, electrical devices, which helps us to step up or step down an alternating current depending on the ratio of the primary and the secondary coils. That means the number of NP and the NS. Transformers can be considered as the step up or step down. That means if the number of the primary coil is less than the number of the secondary coils, this transformer is called step up transformer. But if the number of primary coil is greater than the number of the secondary coil, this transformer is called the step down. That means it reduces output voltages. In this case, it increases the output voltages. So a step up transformer increases the output voltages of the alternating current, and the step down is decreases the values of the output voltages. So in this case, we can see that the number of the secondary coil is greater than the number of primary. This means the transformer is the step up transformer. That means the number of primary is less than that of the secondary. So to find the amount of the output voltage in the secondary coils, we use the equation which is called the transformer ratio, which says that the ratio of the primary coil to that of the secondary is always equal to the ratio of the primary voltage divided by that of the secondary. So from this equation, V of the secondary is always equal to the ratio of the secondary to the primary times the voltage of the primary. So if we substitute the number into this value, Vs is equals to Ns is 1000 times the V of the primary is 12 volt divided by Np is only 600. So we can cancel this 0. 6 by 6 is 1 and 12 by 6 is 2. So this is 10 times 2 volt, which is equals to 20 volt of the output. So since the Vs is greater than the V primary, the transformer is the step up, as we have said. So the correct answer is on alternative C. So this question says, which of the following statement is differentiate emitter, collector, and base of a transistor? So as we know, transistor is an electronic devices which helps us to switch or amplify the electronic signals. So we can classify transistors as the bipolar junction BJT or bipolar junction transistor. The other forms of a transistor is what we call the MOSFET, metal oxide field effect transistor. So we don't consider the MOSFET but only the BJT. So BJT has two structures, the PNP and NPN. PNP means when the N-type semiconductor is sandwiched between the two P semiconductors type. NPN means when the P-type semiconductor is sandwiched between the two N semiconductors. So the middle terminal, this middle terminal is what we call the base, and the other side terminals of the base is what we call emitter and the collectors. When we consider the size and the doping percent of the emitter, collector, and the base, so the emitter supplies the charge carrier, that means either electrons or the hole. Emitter is the heavily doped, and when we come to its size, it is the moderate or the medium sizes. When we come to the collector is the section of transistors which collects charge carriers. So it is moderately doped and it is very large in size, or it is very thick in size. When we come to the base is lessly doped and very thin compared to the collector and emitter. So the alternatives of the each question says alternative A, the emitter region is heavily doped as compared with base and collector. So the emitter is heavily doped when compared to the collector and the base. It is true. And the B says the collector region is heavily doped compared to the emitter and the base. So the collector region is moderately doped when compared to the base and the emitter. It's not true. And C says the base region is heavily doped as compared with the base and collector, but the base terminal is lessly doped as compared with the emitter and the collector. So it is not correct. Alternative C says the three parties, emitter, base, and collectors, are equally doped. They are not equally doped. So the heavily doped is the emitter, moderately doped is the collector, and the base is the less doped. So doping means simply adding the impurity to the semiconductors to improve its conductivity or to get more charge carrier from that semiconductor devices. So the correct answer is A, which says the emitter is the heavily doped compared to the collector and the base terminal of the transistor. Question number 20 says, the following figure shows a switch of circuit consisting of a battery source, two switches represented by letter A and B, and a light bulb Y. So this is the circuit given. Two switches A and B are in parallel connected to the battery N and then to the bulb Y. Which of the following logic gate can be represented by the equivalent switch circuits? So as we know that, so two switch in parallel means it represents the OR gates of the logic. That means it is equivalent to the OR gate. Two switches in parallel always represents the OR gate. That means either A or B is works to light up this bulbous Y. So we call it as a OR gate. So when a force F is applied to the wire of length L fixed at one end, the wire extends by X. Then the tensile strain of the wire is given by. So strain is simply a kind of deformation which is caused by the stress, while the stress is simply the force acting on the surfaces per that surface is what we call stress. So strain is the deformation caused by this stress. So it's mathematically tensile strain is given by the extension or the deformation of material divided by its original length x over L. So from the alternative, simply we can see that the tensile strain of the wire is the length L divided by the extension of the wire. So it is not true. So the tensile strain is the extension X divided by the length or the original length of the wire. So it is true. It is the product of the force F and the extension. No, it's completely force. The D is the applied force F divided by the extension is also not a strain. So the strain is the extension of the material divided by the length is what we call the tensile strain or the deformation caused by the stress or the force applied simply. So the correct answer is on alternative B.